Scaling up is the next big thing, because we need to invent new mechanisms in order to give visibility, to give confidence for the private sector, for the industry to invest in this new technology. So we really need to think out of the box in order to reduce the uncertainty. And we need also to scale up. And the scaling up, one of the true leverage that we're using today is the IPCEI. It was mentioned this morning, we have an IPCEI ongoing on hydrogen. That will be key to facilitate the takeoff of the market. But we need to better connect the IPCEI with the research and innovation. And last but not least, I make the bet that by the end of the decade, we'll not talk about gigafactories anymore, but rather about terafactories. Last but not least, I would like to say that with hydrogen, we have a unique opportunity that we should not miss. I mean, we need to be very careful. It's not a done deal yet. We really need to work hard. We need to deliver now. But many people consider that climate change is a curse. I would like to conclude by saying that for many industries, it could also be a huge opportunity.
Thank you so much, Valerie. That was extremely clear. Hydrogen is needed. Hydrogen is offering unique opportunity. And what we need from R&I policy is synergies, scaling up, and better connecting the dots. So that was absolutely very clear. Let me move on to Joseph, the chairman of the European Nuclear Cogeneration Industry Initiative, also member of the governing board of the Sustainable Nuclear ETP, and Joseph is also an advisor to the Polish Minister of Climate and Environment. So the next 2 minutes are yours. What should the EU R&I policy do for the European industry?
Thank you very much, Rosalinda. I usually like, as a physicist, to bring something on the ground level, to look where we are and what we need to achieve. As a Europe also. Look, there is so, when we take into account some total final energy consumption by end user in Europe, this is from Eurostat, you can take this, electricity delivered around 23% only for energy, final consumption. From this electricity, only 32% is generated by the most popular renewable energy, hydro, wind, solar. They directly produce electricity. This means that these three renewables deliver around 7-8% of total final energy consumption only. 7-8% of total consumption energy in Europe. When including in this the biofuels, what is a reasonable amount, then in final consumption, the resources combined achieve something around 20%. It is 1/5 of total energy consumption in Europe. At the same time, fossil fuels, coal, oil, gas, produce more than 60% of final energy consumption, specifically in heating and transportation. And very clearly, this means that an effective European decarbonization strategy must urgently place more focus on the two strategically important sectors. Regards hydrogen. Hydrogen is often presented as a silver bullet solution for decarbonization. But hydrogen is only the energy carrier, not an energy source. This is energy carrier. Hydrogen needs to be produced first, and this is this very energy-intensive process. Current use of hydrogen in the European Union is about 10 megatons per year, mainly for petrochemical and fertilizer industry. It is essentially produced by steam reforming of natural gas, which emits real large amounts of CO2 in this process. If we now moved to low-temperature clean electrolysis instead, with this whole renewable energy, we can produce in this low-temperature clean electrolysis some amount, about 2 megaton hydrogen per year. That's depending on the compression and other. But what this means? This means that with whole current renewable energy, we can produce 18% of current hydrogen use. In this, of course, in this moment, electricity would be not available for the other purposes. Remember, today, 18% currently needed hydrogen can be produced from renewable. If we are talking now about mobility, electromobility, if you're talking about other possibilities, the heating and transportation, maybe not electromobility in this moment, that means that the amount of hydrogen will be need to, I don't know, to triple, to quadruple, to this amount that we have. And now we have only 1/5 this what we need if we use all renewable energy. What it means for me as a nuclear, this is important. If you want to go for deep decarbonization, then the primary energy demand would be so high that I can't see no net zero without nuclear. I do not think that Europe has the luxury to renounce to one of the biggest low carbon energy sources that is available to us. And I am very happy because in one of the slides, I saw that the people propose as a main source of energy for 2050 nuclear. Thank you very much.
Thank you, Joseph. That's also a very clear message. No net zero without nuclear, and hydrogen is no silver bullet. Very good. Let's move on to our next speaker who is joining us online. Axel, also warm welcome to you. Axel is Director General of Eurofair. And before joining Eurofair, Axel has been working also in the European Parliament on waste legislation. And the office Axel was working was often referred to as the scrap office. That, of course, is also now playing a very important role for the circular economy. I also was told, Axel, that you are not a big fan of the former US President, Mr. Trump, but that you have been using one of Mr. Trump's quotes that was, "Without steel, you don't have a country." So that's a bit of a selective quotation here, Axel. So now you have 2 minutes for your pitch on what European research and innovation can do for the competitiveness of the energy industry. Axel, welcome, and the floor is yours.
Thanks a lot, Rosalinde, and good afternoon, everybody. Of course, this quote from the US president is today or in the past also already used by many countries to establish a domestic steel industry with governmental support schemes and subsidies, which leads to a situation that the European steel market is often flooded with dumped or subsidized products. So this is one major cause of global steel excess capacity and a major cause why our sector is constantly in some trouble, to say so. Coming to the decarbonization of our industry and what the R&D agenda of the EU can do on that. First of all, the European steel industry supports, of course, the objectives of the European Union to reduce emissions by 55% in 2030 and to become carbon neutral in 2050. The ambition of our industry is to reduce our emissions by another 30% in just 10 years up to 2030, which would be 55% compared to 1990 levels. And then by 2050, our sector's ambition is to be carbon neutral. We have probably one of the largest agendas of decarbonization projects among industries in Europe. We have just a few weeks ago also made public a mapping of 54 projects which will reduce emissions by approximately 76 million tons of CO2 or 1/3 of all the EU steel industry's emissions by 2030 already. And some projects will be scaled up to industrial scale already in 2025-26. The capital expenditure for that is 25 billion euros, and the operational cost is estimated up to 2030 at 45 billion euros. So these are huge amounts, and we come later to the challenges of that. What we will require by 2030, of course, is then also a huge amount of CO2 low, renewable or carbon neutral electricity. We will need 150 terawatt hours of electricity by 2030, of which half will be needed for the production of 1.7 million tons of hydrogen. By 2050, we will need 400 terawatt hours. That is 7 times of today's electricity purchase of our industry. It is almost the size of the entire electricity consumption of France. And out of these 400 terawatt hours, we will need around about 3/5, so to produce 5.5 million tons of hydrogen. So that is a major challenge. The set plan, of course, plays here a very important role because it helps to achieve both technology and energy supply. It helps access to funding for CO2 low technologies, and it helps creating synergies between funding schemes. So what, of course, is the main objective for us is to have access to affordable CO2 low and carbon neutral energy. That's the main objective for our industry when you talk about the energy agenda. We need, of course, then supply in sufficient amount and timely, because this will be a huge challenge. And the person, Rob, who just talked about this before, we are not sure whether all this could be provided without nuclear energy or the hydrogen we will need. So that is something that has to be debated. The efficient use of the energy, this is also very important, and there the R&D agenda of the EU is also helping here. We as a steel industry are in particular looking for our technologies into the Clean Steel Partnership Innovation Fund. IPCIs, the hydrogen IPCI has been mentioned there. Hopefully, maybe I've missed it, but I hope that this will be finalized now by DG Competition, because we are also working on or want to work on an IPCI for low carbon industry. And there, of course, the energy question plays also a major role. I stop here for the moment. Thank you.
Thank you very much, Axel, for underlining the need for huge investments, also huge amounts of renewable electricity, the importance of synergies between the different funding schemes, the importance of the IPCIs, and of course also thank you for mentioning the issues of affordability and energy efficiency. I would like to move on now to Anne-Chloé, who is here with me, Innovation Manager at CEFIC, which is the European Chemical Industry Council. And Anne-Chloé also coordinates the national technology platforms for the EU platform for sustainable chemistry. What we cannot find in your CV is that you are a frequent traveler to India because you have family members there, and that often you also fly in the plane that is flown by your brother, who is a pilot, and that therefore you have a specific interest in low carbon aviation, and that you are a firm believer in hydrogen in this respect. So I see here a similarity with Valérie, and actually you also have another similarity with Valérie, because I'm told that in your free time you make very nice jewelry with stones from India. So I see here a very nice friendship emerging. But before we further explore this friendship, the 2 minutes are yours for your pitch on what European research innovation can do for industry.
Okay, thank you very much. Thank you for inviting me to this panel. For the chemical sector, evidently is a major contributor for the energy transition. It provides employment to over 1 million people. It's, I think, important to state. And it's a solution provider to almost all value chains. And that's where the complexity of the research and innovation agenda for the chemical industry is not only we reduce our CO2 emissions on our sites, but we also develop materials for wind blades. We develop materials for batteries, so we have a direct involvement in lowering the carbon footprint, the overall carbon footprint, basically. we have already done some CO2 emissions reduction, like we reduced from 325 million tons of CO2 in 1990 to 135 million tons in 2017, which is quite a lot. We did this through mainly energy efficiency improvements and use of less carbon-intensive energy sources. But then now we have huge challenges, and the one example I would say is the cracker, how to electrify our crackers, knowing that a lot of chemical products, a lot of the carbon footprint in products is coming actually from the cracker. So now we have several projects started to develop an e-cracker. The big challenge is that it's going to take several years. So I would state this as one of the biggest challenge, how we can accelerate this. And again, it's through collaboration, through the support of the RNI ecosystem, European ecosystem, together between member states, regional funds, and European funds. So for us, it's extremely important. The set plan has given us the opportunity to list all the different technologies, because there are like many. We have, of course, the integration of the climate neutral energy in our processes. What it means is it means converting the heat into electricity. But then we also have process efficiency, like all the development of membranes for separation, for CO2 capture, for example. I mean, there are like many, many examples. And then we also have, and that's also a very important aspect for us, is the better utilization of alternative carbon sources. And I say alternative carbon sources, not alternative feedstocks anymore, because we don't want to eliminate carbon. We use as alternative carbon sources biomass, contains carbon. We use waste, plastics waste or other types of waste, also containing carbon. And then CO2, conversion of CO2 and CO is also a big technology agenda for us. I would say that we welcome the initiative launched by DG Clima on restoring sustainable carbon cycle. So that's part of the agenda, and that's where I would leave it for now. We also are talking about hydrogen. So for us, hydrogen is mainly a feedstock, as Joseph was mentioning. But then we have now projects already started on photoelectrocatalysis to make pure renewable hydrogen. So I think that's an interesting point also to make.
Thank you very much. And to really underline also the importance of reducing the carbon footprint and the fact that it's very important that the set plan has allowed this collaboration between EU and national level. And also thank you for pointing out opportunities by using alternative carbon sources. So last but not least, we go back to our online speaker, Rob van der Meer. Welcome to you as well. I see that you are with us from a very interesting place. Rob is the Industrial Policy Director of the CEM Bureau, which is the European Cement Association. And Rob, I'm told that you were one of the participants in the first international conference on carbon dioxide removal in Amsterdam in 1992. So if there's anybody, either in the audience or with us online, who was also at this international conference on carbon dioxide removal in Amsterdam in 1992, you are the big winner of a free virtual coffee with Rob after this conference. So if there's anybody who was there in 1992 with Rob, please make yourself known to the conference organizers and we will set up this free virtual coffee with Rob after this conference. Before that, Rob, we move to you for your 2 minutes on what R&I policy can do for industry.
Thank you. And yes, indeed, I was in Amsterdam at that time, and it was a pleasure to be there. And hopefully there's someone else also in this meeting. My apologies for not being able to come to you for this meeting. I had to stay at home for several reasons. But I wanted to talk a little bit about innovation and why is this important for cement industry. And we start, of course, with a lot of obvious remarks, but I wanted to start from a different perspective. Innovation in cement and innovation in concrete industry in the global world is started always in Europe. That's today the case, that is already 100 years the case or even longer, and I expect that it will be the case in the next 20 years too. So that really stresses that if you want to decarbonize the European cement world or the global cement world, you have to start in Europe. That as a starting point. I also wanted to make a statement that the best cement plants in the world from a carbon perspective are operating in Europe. That's always underestimated by other people because new plants are being constructed in China, in India, but really the best performing plants are in Europe. And that's interesting to know. Now, when talking about innovation, I always think that we have to think about the three pillars, the concrete pillars, I would say, of a decarbonation house. For decarbonization of the industry, I think that we need to identify three pillars. And the first one is the technical pillar. That is about use of hydrogen, electricity, but also other materials, new products, changing current products into better products, low carbon products. That is the technical development. And for that, it's very important that it is continued and that the support is from Europe, from the countries, is continued to the cement industry and I guess to any sector. The second pillar, I would say, is the infrastructure pillar of this infrastructure that we need for decarbonizing the industry. And that is about hydrogen, that is about renewable electricity, that is about CO2, but it's also about waste materials that have to be recycled, reused. And that infrastructure is really the second pillar that we need. And for that, also a lot of innovative developments are needed. The third pillar, I would put it for me at the left, is the pillar of the policy societal framework that we need. And that is a challenge from a European perspective, but not for today. I would like to focus on the technical pillar. The technical pillar, when you look at cement, 60% of our emissions are coming from process emissions, unavoidable emissions by normal technology, except when you go for carbon capture and use, carbon capture and storage, that type of technology. But from a technical perspective, these process emissions, 60% for cement, are a big challenge. The other part are the energy combustion emissions. And when you know that cement industry in Europe reduced its emissions already with 15% since 1990, that sounds not that impressive. 15% over 30 years, okay, not that impressive. But when you recognize that 60% of the emissions not reduced by 50%, it means the 15 is in practice 40%. And that is really a message that we have to convey. So there is a lot of possibilities for the future, and I don't want to go too much in detail because I'm also limited in time. It means for me, as a conclusion of this first round, that innovation in cement and concrete, but also the other energy-intensive sectors, combined with the structural, infrastructural demand and setup, it's an interesting project concept for that, combined with a political societal framework, could help us to achieve that low carbon, or in fact carbon neutral society, which is the ambition of the cement industry for 2050 in Europe. Thank you.
Thank you very much, Rob, for this very clear pitch with your three pillars: technology, infrastructure, and society. Okay, let me just see whether everybody is still awake in the audience, because I'm not sure this is the case. So please take on your phones and let's go for the second Slido poll question. The question here to you is, in your opinion, which energy technology trends will have the greatest impact on our industry over the next years? So the floor is open. We should have a word cloud forming behind. Or maybe not. If everybody is sleeping, there will be no word cloud, and then the screen will remain completely blank. So, while, there's something happening here. Very, very good. Okay, we let everybody in the audience, both here in the conference center, but also online, wake up and participate in the Slido poll question. In the meantime, I'm going to the second round, where I will have some more specific questions so we can dive a bit deeper with our industrial leaders here. Valérie, if it's okay, I will start with you first. We already heard some different opinions on hydrogen, also from the other panelists. So basically, please could you enlighten us what role you think hydrogen will have to play in the energy mix as an enabler in the clean energy transition, whilst also, of course, boosting our sustainable industrial growth. Valérie, you have again 2 minutes.
Okay, thank you. Joseph stated something which is really true, is that hydrogen is no silver bullet. Hydrogen is needed, but we also need other technologies. And hydrogen is an energy carrier, we totally agree, but it brings flexibility to the energy system grid. And it can carry a lot of amount of hydrogen, of energy, whatever the time, whatever the space, and it can be bulk storage, so which is a very good leverage whenever we want to achieve a target in terms of renewable energy in the electricity grid. What is so interesting is that hydrogen is not a newcomer. For many, many decades, hydrogen has been used in the industry. We're talking about 70 million tons a year already being used, but hydrogen is also a nice energy carrier and a nice tool for the future industries. And where we're talking about decarbonating transport, intensive and heavy-duty mobility, that's where hydrogen can play a role. When we're talking about decarbonating industry, and Alex is representing the steel industry, hydrogen will be a true game changer in helping the steel industry to decarbonate. So we can see that even an old energy carrier can also participate and contribute in achieving net zero emission. I will dare also to talk about nuclear and nuclear assets, not only because I'm French, but also because I think that we need to use all the electricity sources, low carbon electricity sources that are available. And when you use hydrogen, I mean using nuclear electricity, then you can reach a very low CO2 intensity. And on top of that, you can also use existing assets. You don't need to create new assets. You have already existing one. And because we'll need huge amount of electricity, I mean, we need also to have an holistic approach and to take into consideration what we have today, what we need to build. We talk a lot about the small modular reactors for nuclear. I mean, we need to investigate every single low carbon technology which is available.
That's very clear, and you make a really good bridge to Joseph, who I will now give the floor in a second. And also looking at the results from our polls on which energy technology trends will have the greatest impact on our industry over the next years, you can really see two things. It's hydrogen, according to our audience, and the small nuclear reactors. So this begs for a reaction from you, Joseph. And in particular, would you also see the production of pink hydrogen as a very important part of our future energy mix?
Okay, maybe first about small hydrogen reactor and later about the pink hydrogen, okay? Yes, small modular reactors, this is something what now is opened as a very new development, very futurable now. And there are two areas where the SMRs can deliver an important impact on the European economy. First, it is the impact on the electricity production through the reduction of capex. You know, the huge power reactor have one unpleasant feature. they cost too much, quite simple. This is a huge capex requirements that negatively influences the leverage cost of electricity. And of course, the financing cost can reach in the big reactor on average 70% of the final average cost of electricity. This is, of course, very good business for finance institution, but certainly not for customers. The second important impact is the possibility, and by the way, of course, we can produce now the hydrogen using these power reactors and adding, for example, the heat from reactors, because reactors' primary product is a heat, not electricity. Involving this heat is around 300 degrees Celsius. We can be more efficient as in the normal temperature. That is something what is very useful, and there is a lot of economical investigation. There is very good option. To using this what we have. SMRs, of course, allow this also, especially in the industry areas, directly nearly to the industry places, because small reactors have usually a small EPZ zone, and there is easier to locate them, if the people allow, of course. And the second important impact is the possibility to decarbonize industry and transport. In this, my first statement, I told you that in the final energy consumption by end user, we have a 60% used for heating and transportation that is fully covered by fossil fuel, mostly gas and coal, yes? And using existing technology that we have now of high temperature nuclear reactors, they are also SMR reactors, also they use the name AMR, we can produce the very large heat demand easily up to 700 degrees Celsius on the output of the reactor. What it means? That we can, with this reactor, deliver the industry steam, 550 degrees, what is very likely for chemical fertilizer industry, with huge amount and very and stable and as you wish, quite simple, on demand. And these high temperature reactors can also be developed in the next version. There is also now exist in the research 1000 degree hydrogen. And I'm coming to the end, sorry. And that is very important for Europe because these both technologies are really ready. That means the first SMRs of both types, water and gas cooled, if you want, we can build them up to end of this decade, up to 2030. This is the decision only. The technology is enough mature to doing this. And if you are not doing this, of course, the other will be doing this. And for example, there is now very rush development, especially in China, North America, and by the way, the United Kingdom, and this is not Europe now.
Okay.
And on the last, the pink hydrogen. I don't like these colors because pink for me is the color that like my daughter, but she's 12 years old. I usually think about clean or not clean hydrogen. We need to set some level of CO2 emission and say is something clean or not. And it will be so easier and not making these different colors what is, for me, is not very understanding. Okay, again. No net zero without nuclear. Thank you.
Thank you, Joseph. Let's quickly move on to the cement sector. Rob, could you please share with us what you see as main options to green the cement sector to meet our climate ambitions? 2 minutes maximum, please, Rob.
So I have to be very fast. First, I said already that it is not only about energy, because energy is only contributing only 30% of the emissions. So talking about hydrogen or electrification or biomass fuels will help the cement industry to decarbonize, but only for that 30%. So we really have to look in new products, low carbon cements, low carbon concrete, and we have to look, don't forget that, carbon capture, use and storage. That is a fundamental aspect for cement industry to achieve that carbon neutrality. So, and there is not a single option. Not that we do it only this year, only. It has to be all. And that's the challenge that I think. So asking a priority, for instance, on what we should do, the answer is we should not have priority. We should do them all. So back to the point, energy, yes, hydrogen, not up to 100%, but I assume up to 20% of use of energy by the cement industry. Electricity, yes, perhaps we will see electrical kilns with plasma type of kilns, very challenging, never done before, but also carbon capture and use. And finally, we have to move into these low carbon projects. And that is a challenge also for the society. How to accept these new products? How do we get that in the market? That is a big question. And I don't have the answers, but I see that as a challenge. Thank you. 2 minutes?
Excellent, Rob. Thank you very much, and also thank you for mentioning the societal dimension and the importance also of acceptance of society of new technologies. I have the same question, Axel. We are moving to you. So, what do you see as main options to green the steel sector?
I actually agree with Rob that we need a set of technology approaches to decarbonize and to green the economy, to make the economy circular. One part is, of course, the hydrogen use, but also carbon capture use and storage. So there is a number of technologies which we need to support here. This is due to the fact that the eventual applicability of a certain technology is subject to regional conditions, most importantly, energy costs, energy availability, infrastructure availability, local extent of industrialization, local legal restrictions, or the actual technology readiness level achieved. So therefore, again, this plan, the set plan, but also the whole research agenda and support agenda, the funding agenda of the EU is very important. And I must really say this, that in the last 2 years, there has been made a major step forward in that by the EU. So funding is available for R&D. We need now funding for the scaling up, more funding for the scaling up to industrial scale. We see that for the steel industry, yes, hydrogen will be the major energy vector which we will use. But how to come to that? When you look into how much electricity will be needed for the energy intensive industries as a whole, that's 3,000 terawatt hours approximately. That's a doubling of the total EU electricity consumption. So for that reason, at least in the transition, we need all the options. For example, when we have not sufficient hydrogen available, the steel industry can also use natural gas and then blend the natural gas with hydrogen more and more according to the availability of hydrogen. But then also only the production of the energy is not the solution. We need also the infrastructures for that. And there we need a much quicker approach in the member states to realize that permitting of energy infrastructures takes years sometimes. And I see this in my industry when they are now when they need more electricity, either they import the hydrogen or will import the hydrogen, or they produce the hydrogen on site, then they need electricity. It is a challenge to get all the infrastructure timely in place.
Excellent. Thank you very much, Axel. And I'm quickly moving now to you, Anne, with the same question, but we're moving to greening the chemical sector. So what do you see as the main options there? Should we use more biomass in biorefineries? Should we reuse CO2? Please enlighten us, Anne. What should we do?
Right. So as I mentioned before, we have the option of using different feedstocks like biomass, waste, and also CO2. So it's not an or, it's it's a combination of the different feedstocks, and it very much depends on the local situation of a petrochemical site or chemical plant. The access to the biomass is important. It has to be accessible locally. But of course, it's quite complex because we have to meet the circular economy objectives. So we do have to contribute to the circularity of plastics. So what we have been doing recently, this will be published soon. We have developed a model which is looking at different scenarios. So we have listed all the different low carbon technologies I was mentioning before. And then we can see what is the effect of using more biomass or more waste or more CO2. And that's quite interesting. I think that's it basically.
Okay, thank you very much, Anne. I fear that we have come almost to the end of our session today. I think this has been a really very interesting discussion with top leaders from the industry in the European Union. We have heard that there's basically no silver bullet to green our sectors, but that we need massive investments, that we need massive amounts of renewable energy available in the future, that we need to connect the dots between the different funding schemes that are available in the European Union, and that the set plan has and will continue to play a very important role in connecting these dots and ensuring that we can move from research and innovation to further deployment and scaling up. So I would like to conclude this session basically by doing once more a tour of our very impressive panelists. And I would really ask all of you to stick to one sentence. And Joseph, I'm restricting you to 3 words. And basically the question is to wrap up this session, that you will also make my life easier, because then I don't need to conclude any further. So please, distinguished panelists, share with us in 1 sentence or 3 words, what are your expectations for the future set plan to make all this happen? And let me start with Axel. You may start.
Continue to find the right synergies between the programs and the approaches.
Thank you. Then we go to Valérie.
We are probably facing the biggest issue that humankind will ever had, and I'm totally convinced that with hydrogen we can achieve the goal, and we can also at the same time create economic growth, jobs, connection.
Joseph.
Thank you that I am here, because I am from nuclear, and the last set plan was nuclear was not involved. And I think that now everybody knows that we can bring some valuable input to energy, to a European Green Deal. No nuclear, no net zero without nuclear. Thank you.
Anne-Chloé, please.
I think on the set plan side, I think it's going the right direction. Maybe we could ask for more representation of the member states. Sometimes the member states are there on their own interest or because they have a big interest, but we would like to see more. But I'm in the same direction as Axel, is the linkages between the different funding schemes, the overarching agenda that we need to have clarity. And I would make a special point on these industrial roadmaps, which are being developed now. So low carbon technology, circular economy. So hopefully we have a document which is linked with the set plan agenda. Thank you.
And the last sentence is for Rob.
Yeah, my journey in carbon dioxide removal started, as known, in 1992. Now we see with the EU ETS Innovation Fund suddenly popping up carbon capture and storage projects popping up in Europe. And I think that is really promising for the next years, and set plan should contribute actively in that. Thanks.
Thank you very much. You were an amazing panel, and also you were an amazing audience. There were also questions from the audience. Unfortunately, we didn't have time to answer them now in this session, but I will ask our panelists to take the time and to answer these questions after the session, because I think it's indeed very valuable. Thank you so much for your energy, and I'm really looking forward to the continuation of this conference.